Welcome back to our daily stand-up series, and this is going to be the system design version of the series. So the problem for today is we need to design a back-end system as well as a front-end application that is able to display real-time notifications. So the problem is, how do we allow the front end to continue as normal while providing updates from the back end? So what we're going to do is, we are in our freeform application. This is one of my favorite, really easy to use diagramming systems on Mac. It comes with your Mac, so it's very, very convenient. It's super easy. I'm not super concerned about like the semantics of our diagram itself, so I'll kind of get into that. So this is our front end. It doesn't matter what it's written in. It could be React, it could be vanilla JavaScript, whatever you want. But for our purposes, we're just going to have the front end here. And then I'm going to draw another shape here for the back end. Now I am going to specify we're going to be using .NET because that's what we do on this channel. So I have a back end of .NET and a front end. And the front end, for a typical problem, whenever you have a system design problem, it doesn't really matter in a sense what the application is doing. What you really want to focus on is how the data is moving. So the principles of that can apply pretty much across the board, whether you're making a library application, a booking application. It really doesn't matter. Conceptually, it's going to be very similar. So we have a backend in .NET, and all we're going to do to denote that there's some form of communication happening is we're just going to draw a line here, and we're going to make it both ways, which is convenient. So you can do that in free form. So we've established that there's communication from the front end. I'd imagine that there's going to be some API call to the back end. Again, it doesn't matter. And then we're going to just draw, we're going to have a basic database. Again, it doesn't matter what the database is, but we're going to be performing write and read operations to and from the database. So this is a typical flow, right, of an application. It could be a microservice. It could be, a monolithic front end calling some .NET API that connects to a database. It really doesn't matter, but this is how we have it. So the problem is, how are we going to show real-time updates, notifications from the back end to our front end? So the general flow is going to be like this. We need a way for this. We'll make this in red to show it's new, and let's give it a little bit of text. So we want this to say notifications. And the notifications, again, doesn't matter what they actually are. They could be, you can think about it, they could be an update to when a record in the database changed. They could be an update to when the back end has finished processing something. It doesn't matter. What really matters is how the back end is going to be sending those notifications to the front end. So that's what we have to think about. And some things you should consider are, the front end should not be waiting at all on the back end to provide those updates. We want it to be as asynchronous as possible. So the front end needs to be notified of a change. So you can think about this as, we're going to be focusing on event-driven design. Event-driven design is not a waiting paradigm, right? Event-driven design means that we're going to be receiving something as we are currently already doing something. So event-driven design is very nice, and that's the focus that we're going to be having. So let's put that up there just to keep in our minds. So with that in mind, event-driven design, what we're going to establish is a WebSocket connection from the front end to the back end to open up this asynchronous basically method of communication that doesn't rely on the typical request response paradigm of a REST API. So what we're going to do is we're going to just update this text here to say we're going to use WebSockets. And to get specific, we're going to say we're using signalR, which is .NET's implementation of WebSockets. So the front end will have a library that can accommodate signalR, and .NET has signalR you can add into the middleware pipeline. And then we basically will create in the code handlers for that. So we'll register a class that will be used to send a message essentially to the front end whenever it receives, whenever it's triggered, whenever it receives something. So basically what we can establish here, we'll just add a little bit of a logic blurb here. We'll just make that red. So this is going to be some logic here, and send message to front end. And basically this is going to show that, okay, our .NET backend is going to send a message via signalR, so using WebSockets to the front end. The front end is going to receive that information, and it could display that on the could display that on a table, could display that in a header, display wherever you want. The key thing to know with this is that because we're using WebSockets, we're avoiding the typical request response paradigm of our REST API, and the front end can continue operating without having to wait at all on the back end. So real-time notifications is actually a very simple thing to implement, and .NET makes it very easy to do that. And for me, I have the most experience with React, and using React to implement signalR, or to work with .NET's signalR package, is very, very simple. And I have videos on this channel where we go step by step making the code to do this. If you're interested, I have all those videos in the Software Engineer Experience playlist. So if you want to go look at that, I've already done that. But I want to show you this as a simple way of how to do this. This is basically all you need at a high level to do this. And so if you are ever tasked with creating real-time notifications, the easiest, or one of the easiest solutions, again, there's a million different ways to do this, is to just introduce WebSockets into your application and have the front end be registered to listen to that, to listen to the back end, essentially, is what is happening. So if you can introduce this into your system design, again, this is one solution of many. You can get way more technical, you can get way more involved depending on how you want to go, because we've really only focused on the front end's responsibility in terms of how it's going to listen. We haven't really focused at all on how the backend is going to receive those notifications, or how is the backend going to know when to send a message. So that's something to ask in the interview is, do you want to go more in depth in terms of how the backend is going to send the message? Because that's important too, because you don't want to create a bottleneck on the backend where we have to send these messages in some existing logic pipeline. And so you want to just bring that up in the interview. And if they do want you to go more in depth into the backend portion in terms of how we're actually going to be sending those messages, then you could introduce things like queues, and actually expand more on event-driven design. And you can break this up a lot. Again, you can get very, very creative in terms of how you do this, but conceptually, what is in red will get you a first draft of a working solution of real-time notifications with .NET. So that's all I have for today, so I will see you on the next one.